my dear students, and welcome to our science class. Today we're going to talk about motion. I want you to look at this picture. This girl is in motion. She is skating on the ice. What is motion and how we describe it? According to what? Let's get started. Now, as you can see here, these jellyfish are in motion. They are swimming underwater. Our planet Earth is in motion too. It orbits the sun every year and it's spinning around its axis every day. So everything is moving around us. Everything is moving around us. Each child in this picture is standing in a specific position. What's the meaning of position? It means certain place. It means a certain place. Now we call the presence of something in a certain place the possession of that thing. So this is the possession of this girl. This is the possession of this boy. And this is the possession of this boy. Now how we describe the position. How we describe position. As you learned in previous classes, you use position words like between, in front of, behind, to the left of, to the right of, next to, on, under, and below. Now let's take this exercise. I want you to describe the position of the cat according to each subject in the picture. Let's begin with this one here. The cat is near the chair. You can say near or you can say next to the chair. The cat is under the table. The cat is on the chair. The cat is in the basket. The cat is behind the plant. The cat is in front of the chair. In the last picture, the cat is between the ball and the box. So, to describe position, you can use position words. You can use position words. Now, to this next picture, this girl is walking. This bird is flying. This player is running and he is moving the ball with him. He's kicking the ball and move it with him. So all three objects here are in motion. They are moving. What's the meaning of in motion? What's the meaning of motion? It's any change of position. It's any change of position. So the man is in motion. That means he's changing his position constantly. He's changing his position constantly. Now look at this picture. These cars are in motion. How do you know that these cars are in motion? How do you know that these cars are in motion? Because they are changing their position. How do you know that they are changing their position? Look, they are changing their surrounding too. This car is in here, in this position. Now in this position, now in this position, now in this position. So it's changing its position constantly. That means it's in motion. It's in motion. Now I want you to look at this picture. These bikers are in motion. This one is the winner. Why? Because he moves fastest. He's changing position fastest. Now I want you to look at this picture. This girl here is not moving. How did you know that it's not moving? Because her surrounding is still. But this one here, he is in motion. He's moving because he's changing his position. And you can know it because see the trees? He's passing them by, right? So he's changing, obviously he's changing his position. See? According to his surrounding or things in his surrounding around him, I can say that he's changing his position. So he's in motion. Now, anything or things in my surrounding that I can sense and use to describe motion, this is my frame of reference. So, what is a frame of reference? It's all things around you that you can sense and use to describe motion. Now, look at this picture here. From this window, I can see this house, these flying birds, water, rocks, this beach, right? These things make my frame of reference because I can use these things, I can sense these things and use them to describe motion around me. Now look at this picture. This man is standing on the pavement or on the sidewalk. He's watching the train. Describe the movement of the train to him. Describe the movement of the train to him. You can say that he can see the train is moving. He's passing him by, right? Now, what about passengers in the train, riding the train? If I'm sitting in the train next to you, to me, you are not moving. To me, you are not moving. Things outside are moving because I'm passing them by, right? Again, to a man on the pavement, he can see the movement of the train. So to him, people inside the train are moving. But what about people inside the train sitting next to each other? To them, they are not moving because they are riding the same train at the same speed, So this is called relative motion. This is called relative motion. It is the motion that is described based on a frame of reference. I have a frame of reference, you have a frame of reference. We have different frames of reference. So we have relative motion. Relative motion. I'm going to give you a simpler example. Now you are sitting on your chair watching my video, right? Are you in motion? Are you moving? No. According to you, according to things around you, according to your frame of reference, you are not moving, right? But suppose an astronaut is watching your house from space far away from Earth. The astronaut answer about your movement on Earth will be different because his frame of reference is different. From space, the astronaut sees Earth rotate. Okay? So, motion that is described based on a frame of reference is called relative motion. Relative motion. Now, to other topic, relative topic, of course. This car is moving, the boat is moving. The question, how do I describe whether an object is moving quickly or slowly? Like this girl here, she's walking. This man is running. How do I describe their motion? If they are moving quickly or slowly? Now, when we describe the speed of an object, we are talking about the extent of to which the body's position changes with respect to time. With respect to time. The two measurements that I need to describe the speed, time and distance. Time and distance. Now, what is distance? It's how far something travels. And we can measure distance using a meter. We can measure time using a stopwatch. Now, if we have distance and time, we can easily calculate speed. You cannot describe, remember, you cannot describe motion without a frame of reference. Now, in a race, like this one here, in a swimming race, each swimmer goes the same distance. The one who goes the distance in the least amount of time wins the race. That person has the greatest speed. Now, the swimmer's speed is the distance moved divided by the time it took to move that distance. I'm gonna give you an example. You are riding in a car. You traveled 240 kilometers in 3 hours. Now, I want you to calculate speed. What we gonna do? 240 divided by 3. Distance divided by time. So 240 divided by 3, that's 80 kilometer per hour. Let's take another example. You are riding in a bike. You traveled 30 kilometers. 30 kilometers in 2 hours. Calculate the speed. You're gonna divide 30 over 2. So 30 divided by 2, that's 15 kilometer per hour. 15 kilometer per hour. 30 divided by 2, that's 15 kilometer per hour. Okay? So again, the two measurements you need to calculate speed: time and distance. Time and distance. You're gonna divide distance over time. Then you'll get speed. Okay, sixth graders, that's it for today. I hope you enjoyed my lesson. I know I did. I'll see you next time, inshallah. Have a great time.